Okay, so let us begin with the so in our previous class, we have studied about that what are the prokaryotic solvent, what are polar aprotic solvents. Because this is the important thing which we have to keep in our mind while doing the reactions. Why? Because of the proton releasing group and non-proton releasing group. Remember this thing. These polar protic solvents are considered to be as weak solvents. These are weak solvents. Weak solvent means they first create poles. After that, they just combine with the alkyl group. है ना? Two-step reaction will be there. है ना? So that two-step reactions will make them a slow reactant. मतलब अगर हमारे पास if we have this alkyl group and plus halogen group, so these polar protic solvent wait for removal of this nucleophile. It just waited. ऐसा होता है ना कि भाई if they want to attach with this alkyl group तो इसके जाने का wait करेंगे है ना because of their weak character. But in the case of your polar aprotic solvent in SN2 reactions, they do not wait for removal of alkyl group. They just simply come and attack from the back side. And when they attack, nucleophile attacks from the back side, ultimately this halogen will remove out. So ये इतना time ही नहीं देते हैं. This reaction actually happened within 10 to the power minus 6 seconds. तो इतना time ही नहीं होता वहां पर कि भाई they will form some intermediate compound and something. They are strong enough to remove this nucleophile from the alkyl halides. Clear? Okay, so today we will discuss about so many things which are related to the SN2. These types of questions you will get in your board examination. Okay, so we will continue with the same SN2 type of reaction. That what are the factors which are responsible for? Okay, let me just start. So in our previous class we have discussed about solvents already. Okay. Now we will discuss about the next important point, temperature. Better remember this thing. This is the most important thing. This is the most important part of your reaction. Of any reaction, it controls the rate of reaction. And if you increase the temperature, it will change the rate of reaction. If you decrease the temperature, it will also it means the temperature just control the rate of reaction. So for SN1 and SN2, the temperature requirement is low. Same means both the equations occur at low temperature. Clear? So you will not discriminate between both the reaction on the basis of the temperature. And apart of this, both are exothermic reactions. Both are exothermic reactions. Clear? So it means that low temperature directly related to the rate of reaction. How? If you increase the temperature, means it's inversely. It's not directly, it's inversely related to the temperature. How? If you lower the temperature, rate of reaction will increase. If you increase the temperature, rate of reaction will slow down. So they are inversely proportional to each other. Jitna low temperature hoga, utna zyada reaction rate fast hoga. Clear? Okay. Let us talk about next important thing is stereochemistry. What is the stereochemistry? Stereochemistry means if they are means the compound is inversion or the compound is retention or racemic type. So what does means racemic means? Racemic means when we got both the types of product, inversion and retention. I have explained you about inversion and retentions. Okay, they were the plain polarized on the basis of their stereometry. So in case of SN1, I'm telling you about both the things. So note it down so that you can compare between SN1 and SN2. Na? So in SN1, we will get both retention plus inversion. Clear? But In case of SN2, you will get inversion. Clear? So in case of this SN1, this in both retention and inversion product will obtain, but in case of SN2, you will get only always what? Inversion. Note it down. Okay. So let's just move to some important points also. That factors affecting rate of SN2 reaction. Factors affecting rate of SN2 reaction. But first point, we have discussed about solvent, we have discussed about temperature. So I just want to explain you some important points, some important factors which actually just affect the rate of reaction. So you will get different types of questions in objectives out of these. So first one is nature of alkyl halide. First one is nature of alkyl halide. This is the most important thing because this is inversely proportional to SN, means SN1 and SN2 are both inversely proportional. एक दूसरे के opposite चलते हैं. अगर this is going in right, so this will go in left direction. Clear? So you need to understand the difference between SN and S1 and SN2. Since you will get if multiple type of questions, for example, and they will ask you that which reaction will give more SN1, more SN2. So on that question, you will consider all the factors actually. First alkyl group, then we'll go to the, if alkyl groups are same, then we have to go to the solvent. Clear? There are so many factors. So let's just note this thing down, that your reaction rate of reaction is inversely proportional to steric hindrance. Note this down. Can anyone tell me what is steric hindrance? This is the most important point. Any one of you, can any one of you tell me what is steric hindrance, beta? Yes. Anyone wants to tell me about steric hindrance? Clear? Steric hindrance means bulky rush. तो जितनी ज्यादा स्टेरिक इंट्रेंस होगी, जितना ज्यादा भीड़ होगा, उतना ही कम तुम्हारा SN1 रिएक्शन, SN2 रिएक्शन होगा. I will explain you this thing. Don't worry. With the help of example, I'm going to explain you this. Note it down. So reactivity, or you can say rate of reaction, is directly proportional to the steric hindrance, and steric hindrance means bulkiness, rush, भीड़ आप कह सकते हो. ठीक है? Let me just explain you this thing with the help of example. So note down the examples, because this is these examples are the basic questions you will get in your objectives. Okay. Let me just give you examples. For examples, I'm having this. This is CH3. This is CH3. This is CH. Again, CH3. CH3H X. Next, CH3, CH2 X, and last one is the same methyl group. Clear? Now, let's talk about this. This is tertiary, this is secondary, this is primary, and this is methyl. So I just want to tell you about steric hindrance. Steric hindrance का मतलब क्या है? भीड़ भाड़. ठीक है. अब हमने इसको कॉम्पैक्ट में लिखा है. दिस इज अ कॉम्पैक्ट स्ट्रक्चर. अभी भी दिस इज अ कॉम्पैक्ट स्ट्रक्चर. बट इफ यू जस्ट राइट इट इन ओपन चेन स्ट्रक्चर, so what will be the structure? C H H H. Again C. This is also H. This is also H. This is also H. Next C H H H. See how complex this compound is. Means how bulky this compound is. कितना ज़्यादा bulky है. Clear? This is called this thing called steric hindrance, SH. जितनी ज्यादा भीड़ होगी उतना SN2 कम होगा. तो इसमें हमारा सीक्वेंस क्या हुआ? सबसे ज्यादा SN2 होता है मिथाइल में, then primary, then secondary and then tertiary. Note it down. SN2. And for SN1 क्या था? For SN1 tertiary, secondary, primary, then methyl. So they work just opposite to each other. So note this down. This is very, very, very important. Clear? Methyl group is more stable than primary, then secondary, and then tertiary. It actually just totally depend on steric hindrance. If steric hindrance is more, it means it will show less SN2. If steric hindrance is less, it means it will show less, means more steric hindrance, less SN2. More SH, less SN2. Less SH, SH means steric hindrance. I'm just writing in short form. So more SN2. Clear? Note this down. Very, very important. Chalo. Let's just move to the next one. That much all about the alkyl halide. You just have to see the steric hindrance. If the steric hindrance is large, maximum, it means more SN2 will be there. Now we will talk about another type that will be stability of transition state. Stability of transition state. And what is transition state? Which one is the transition state? The intermediate state. The intermediate state in SN2 is considered to be as the transition state. Okay, let me just explain you which one is transition state. So for example, let me just attach this carbon with the X. For example, I am having RX. This is my alkyl halide. Clear? And I am having one strong nucleophile which I want to react with this alkyl halide. So kya hoga? Steric hindrance means we know this thing that in SN2, this nucleophile is the strongest one. This nucleophile is strong. So it will not wait for the alkyl means this halogen to move out of the compound. Instead of waiting for this, it just go from the back side and attacks on alkyl group. This is known as rear side. Rear side means back side. So this is known as rear side. So nucleophile, instead of waiting, why this thing happened? Because this is strong. Because of its strong characteristic, is just attack from the back side, from rear side, and when it attacks, this will be considered to be as the transition state. So let me just draw this thing again here. So at the transition state, this nucleophile get attached with the alkyl group and this halogen will start removing. So this is the state which is known as transition state. So if transition state means it actually depend on which alkyl group. It's depend on alkyl group. If it is strong electron means strong electron withdrawing group, so it is easy for this to attach with the nucleophile very easily. Clear? So if your transition state is stable, then it will show more SN2. Clear? Transition state is stable, more, it means your state is, your SN2 is stable. Again, let me just explain you with the help of example. Okay. Let me give you some questions. For example, this is A. ध्यान से देखना. Which type of carbon means atom is this? CH2Cl. B option is CH2Cl. C option is CH3, CH2, Cl, and D is CH CH2 okay. CH2. Okay, okay, no. Let me just so mix it up with other CH2 CHCl. Yes. So now we have four options. और आपसे ये पूछा जाए, just tell about the which one shows more SN2 among A, B, C, D. Which one shows more SN2 or arrange in the order of increasing SN2, all of these. So how you will arrange? So first thing, let me just tell you what are the important points which you have to consider. First point, steric hindrance. Second point, stability means carbon stability, either is secondary, primary, tertiary. Next is what you have to consider, minus I effect. Can anyone tell me what is minus I effect? You have studied this thing about minus I effect in 11th class. Minus I effect actually works with SN2. So I will explain you this thing how. Yes. And next one is stability of transition state. So these are the factors which we have to consider before arranging these. So let's just start. So for example, let's just talk about this one. So this is methyl, first one, second one. This is primary, this is secondary, and this is also secondary. Right? Carbon is attached with that, and this, and this. So secondary methyl, primary, and secondary. Now we have to arrange all these groups on the basis of their increasing order. Okay. So what is the difference between this secondary and this secondary? What is the major difference? The major difference is electron withdrawing group. Since this is considered to be as best electron withdrawing group, since oxygen is attached with this carbon, which make it strong withdrawing electron withdrawing group. So what happened? This will be considered as more stable than this and that. So your stability arrangement will be A first. If you have strong electron withdrawing group, it means it is so less SN, means more SN2 reaction. After that हमें ये पता है कि किसका ज्यादा होता है फिर मिथाइल. So first we will consider electron withdrawing group, means if we have stable or strong electron withdrawing group, then it will become as on first priority. After that we know methyl groups come. Methyl group matlab B, then primary, then secondary, then C, and then B. So this will be your arrangement. D will show less SN2 and this electron withdrawing group show more SN2. Clear? Let's just move to the exception one. Sometimes we will get some exceptions, some important questions that in which both the compounds show both SN1 as well as SN2. It will show both SN1 and SN2. So at that time, it will become quite impossible for us, means quite difficult for us, not impossible. Nothing is impossible. Quite difficult for us to just discriminate between the companies, between these, that which one shows SN1, which one shows SN2. So let me just give you some questions. If I have benzene, or you can say toluene attached with the bromine, and this CH2Br. So I am just giving you a question that which one shows more SN1? Which one shows SN1? SN1. The question is among which of these shows SN1? In question, in paper, you will get 4 options, but right now I'm giving you 2. only. Which one shows more SN1? अब सुनो बहुत ध्यान से. This is quite confusing. First, I've already told you, in when we talk about SN1, so keep this thing in your mind, that stable carbocation formed in SN1. अगर ये condition वहां पे applicable है, if this is applicable, if you have stable carbocation formed in your compound, it means that will show SN1. So out of these, as you can see, if we attach this, deattach this bromine and this bromine, what will happen? Which will show stable carbocation? This one. Clear? Since this is benzene and we know alternate bonds are there, shifting will be there and it will become a stable compound. So stable carbocation formed by A. So your A will show SN1, more SN1. Clear? If they ask you that which one shows more SN2, so SN2 reaction will be shown by this. Why? 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 This is because of minus I effect. What is minus I effect? Because this phenyl group, in this phenyl group, there is electron shifting and so factors are there, which will cause, minus I effect. So you can just write phenyl group shows minus I effect. That is why minus I effect अगर होगा तो SN1 होगा, अगर ज्यादा मतलब जिसमें होगा वो SN1 शो करेगा, और जहां पर नहीं होता है माइनस आई इफेक्ट, that will show SN2. So SN2 will be shown by B. Sorry. Error. There is an error. SN2 will be shown by this. Minus I effect is related to this now. I've just already told you. I got confused in that here. So minus I effect will be shown by SN2 or in both. So we know that a phenyl group shows minus I effect, and minus I effect is directly related to SN2. More minus I effect will be there, more SN2 will be there. Okay. So as both A means your A compound, this one shows both A means SN1 and SN2. So this is an exception. So sometimes we'll get confused in the product. ना जैसे अभी मैं हो गई थी, तो क्या होता है, because this is a random example. So if you have this type of arrangement that where minus effect, a minus I effect is there, as well as stable carbocation is there. So it means if it is showing minus I effect, this means that it will show SN2. And if stable carbocation formation will take place, it means that it will show SN1 reaction. So in this, both SN1 and SN2 are shown by A. Okay, one more example. These are known as exceptions. So you must learn about the exceptions. BR, this is A, and B1 is BR. Yes. Which one shows SN1 and which one shows SN2? Note it down. When you remove this bromine, so what happens? If you remove this bromine, so plus charge will come over here, plus charge will come over. Okay, this is 1 degree, this is also 1 degree. Note this thing, this is allyl. Remember? Okay, double bond is there, which actually where the multiple bonds are there, it means they will show minus I effect, just like benzene and others. So since we have double bond here, so minus I effect will be there in A. So A will show SN2. Next, if we remove this bromine from the compound, we will get stable carbocation. Stable CC carbocation formation will be there. So A will also show SN1. Clear? So as both SN means SN1 and SN2 are shown by A only. Clear? Let me just explain you one more important topic, means one more important thing, that is nature of nucleophile. Note it down very fast. Means we know this thing that higher the concentration of nucleophile, more is SN2. है ना? More is SN2. Note this thing down. या फिर हम कह सकते हैं stronger is the nucleophile, more SN2. Clear? Note this thing down. Because in SN2 nucleophile just shows direct impact on the reaction. अगर हम nucleophile की concentration बढ़ा देते हैं, it means as more SN2. If stronger nucleophile है, तो then more SN2. Examples. Note it down very carefully. Examples. Generally यही मिलेंगे तुम्हें nucleophiles. So these examples will help you to know that which one is stronger nucleophile and which one is weaker one. So let us talk about stronger one. Stronger matlab for SN2. I will means give you example of SN1 also. Don't worry. So let us talk about first OH. You will get OH from KOH and NaOH. After that CN. You will get it from KCN. Note it down. NaCN. Because these nucleophile will help you to discriminate between SN1 and SN2. अगर आता है तो आप find out करने में these things will become easy for you. OPH, phenyl. KOPH, NaOPH, SH negative, sorry, it's not SH, SN, KSN negative, NaSN negative. Next SP, phenyl भी साथ में आ गया. NaSPH, KSPH, phenyl. I negative, NaI, Ki. CH2 negative, as well as you are very means familiar with this, from where you will get CH2. Next is NH3, and next is RNH2. Note down these or take a screenshot. These are considered to be as the strong nucleophile for SN2. Noted? And for SN1, weak nucleophiles are H2O, CH3OH. So sometimes you will get compound same, but you will get different types of nucleophile. So on the basis of nucleophile, you will be able to find out H2O, CH3OH. As you can see, all have proton. All can form proton. So these are considered to be as weak nucleophiles. H2O, C2H5OH, and CH3OH. These are for SN1 type of reactions. So I have told you about both SN1 and SN2. Clear? Nature of solvent we have already done. Polar protic and polar aprotic we have done. Okay? So this much I just want to explain you in this class. In next class we will get some more questions. Okay, let me just give you one more question very quick. For example, this is CH3Br. You have to find out which one is this for SN1 or SN2. Second one is CH3Br, H2O. So instead of just thinking about it, first चीज हम क्या देखेंगे? पहली चीज इसमें हम कंपेयर करना है which one is SN1 or SN2. Clear? So first thing is, just take a look on this alkyl halide. This is primary, this is tertiary. So clearly पता चल रहा है SN2 है. For second reference, यहाँ SN1 हो गया. For second reference, just consider the nucleophile OH. So clearly says SN2. H2O, it clearly says SN1. So compound बोलेंगे, complete the reaction में क्या आएगा? तो हमें पता है in SN2 we will get only inversion type of product. The product will be like this from back side. Your OH will attack on back side. Clear? Plus Br negative. But in this we will get two types of compound, both state. First one this, I'm just writing in short. OHCCCC. This is CH3, this is CH3, this is CH3. And you have got both inversion and retention. Clear? है ना? Because यहाँ पे क्यों नहीं हो रहा? यहाँ पे क्यों नहीं हो रहा? SN2, why not in B? Because of steric hindrance. जितना ज्यादा steric hindrance होगा उतना ही less SN2 होता है. Clear? That is why B does not show SN1 means SN2 type of reaction. तो हमारे पास तीन चीजें हैं यहाँ देखने के लिए. सबसे पहले take a look on alkyl halide. After that, go to the nucleophile. And if they ask you the reason, so you can write about the steric hindrance. ठीक है? Since in SN2, primary shows more SN2, and in case of SNV, means your third degree will show more SN1. Let's just continue. We will continue with the same topic in next class.